Hello, welcome back. This is the next chapter in C3. Now on the board there is actually the last topic we covered in C3, which was of course exponentials. But the reason I put that up there was just to remind you what we did last time in the last video that we did. Now the next part is kind of sort of going on from that, because in the last video, if you remember at the end, I said we were going to go through some past paper questions and well, generally some exercises. Sorry about that. Got a bit of thing in my throat there. Just to give you a flavour, because I don't think that tutorial was particularly brilliant, and I think I need to demonstrate a bit more, possibly to me when I watch it back and the other people that watch it as well. Okay, so exercise 3.1. Now, just go through a couple of things that you may remember from last time. Y equals a times e to the power x is generally the equation for an exponential, and the differential of an exponential is just the power. So if it's y equals 3 times e to the power of 2x, it'll be dy dx will be 6. Y equals 6. Dy dx equals 6 e to the power of 2x. So if you remember that. And the inverse function was ln, and then that is the inverse of ln of x is the inverse of e to the power x, and so on. Just choosing a few questions here. Sorry, I'm just picking it. Should have thought about this before. Okay, we'll start with the first one. I was going to try and start with a bit of a harder one, but this is okay. Okay, so the first question says sketch the function y equals 2 plus e to the power x. Now, if you remember, this is completely irrelevant over here, but we did something like that. And if you remember, we said that was e to the power x, and that was 1. So if you remember, that was our sort of original idea of what e to the power x would look like. Now we've got this one that says 2 plus e to the power x. Now what does that mean? That is exactly the same as writing y equals e power x plus 2. Just they've decided to write it that way round. Makes absolutely no difference unless there's a negative sign here, but there isn't, so it's the same thing. So what this basically means is, if you remember, this essentially is fx, and if that is fx e to the power x, this is f of x plus 2. And if you remember from your C1 studies, you'll remember that it's moved up to units. So, if you remember that, we'll draw this again. So, same sort of graph, but moved up 2 units. It shouldn't be any different. It looks slightly different, but it shouldn't be. So that's 3, 2 plus 1 is 3. So that's y equals 2 plus e to the power x. So that's the same. So if we can log this one out now. So that is the answer for question 1. I'm going to give you a few things. So that was fairly simple. I'm just going to give you a few questions now to be getting on with. So I'll give you a minute to pause it. It says find the value of find y when x equals 2, and the second question, part of this, is find x when y is 10. Now they seem fairly simple, but not quite as simple as you would first imagine. So I'll just give you a minute to have a go at that. So I'll just give you a few seconds. Right, welcome back if you've had a go. So anyway, we were saying To find the value of y when x is 2. So that's a fairly simple one. So it's just y equals 2 plus e to the power of 2, or 2x. So if we just simply type in our calculator, 2 plus shift e to the power 2. So if you got 9.38, you are correct. Find x when y is 10. This is slightly more difficult. It involves inversing y. So what we do is we rewrite the equation, but just put 10 as in y's place. So 2 plus e to the power x, and then we subtract 2 from both sides. So 8 equals e to the power x. Now to find x, remember we said we do the inverse. So the inverse of 8 equals x. ln of n equals x. So if we do the ln of 8, you should get 2.08, and that should be your answer. So if you got them right, well done. If you didn't, I'll just explain why they're like that. Well, obviously that 1b is quite straightforward. I hope you got that one. It's the 1c that I would have expected a few of you to struggle on. So basically what we did is we subtracted 2 from both sides, and because if you do the inverse of of 8, that gets you the power of x, and then that gets you 2.08. So I can prove that to you now. So assuming you haven't got this, so 10 plus 2, 10 equals 2 plus e to the power x, so e to the power x equals 8. So then we worked out, so if I just do this, what I did there to prove that 2.08 is right, unless my calculator can find me. So we do the inverse, that's that, of 8, sorry I'm looking through the camera screen here. There's that value that we got there, so you can see it on the screen. Basically I've just rounded that one up, and then that gets you that. So using that value, what I'm going to do is press the AC button, so that is stored in the calculator's memory, and go to our shift to get the E function there, copying our answer, and we should get, if this is correct, 10. So all I've done is I've done the inverse of that, of 8 to get e to the power of x, so e to the power x, and then I've copied that 2.079 round up to 2.08, put it in the calculator, bang on 8. Sorry, yeah, should be 8. And then obviously we'd add 2 to this. Oh, I don't need to do that. And that gets you bang on 10. So hopefully that's explained it a little bit. What I was talking about in the tutorial, improved it in the exam question. Now that is probably one of the easier questions you'll see. Let's see if we can pick another one here. We just rub this out. So hopefully if you copied that down, then you should be okay with that. If you haven't, just refer back to our earlier thing there. So the next few are slightly different in the way they're laid out. The reason I'm not going through all of them is because there's quite a few on that list, and I don't think I have time to go through them all. Okay, so the ones I want to go through, if you're following this on the book here, is question 5, because they're quite tricky. I'll just come around and show you for the people that don't have this book. So just switch the camera screen around. I'll be doing question 5 there. So that one that says check. And that's because I need to check myself. Obviously not with me, but you know, I just need. So first one, 5A, or if you want to call it 2A, but just for the purpose of people who have books. 1 plus 2 ln x equals 7. So obviously what we do from here is we subtract 1 from both sides, so 2 ln of x equals 7. And then we do n of x equals 7 over 2, so ln of x equals 3.5. Well, no. So you do ln of x equals 3.5. So in a sec, let me double check. Before I continue to go through with this, I'm just going to double check. You can, if you want to pause the video and continue from there, because that's where you'd get from, and that's probably where you get stuck. So I just need to check that I've done this right before I explain it. Yep. Okay, so what we do from there, if you come back to us, is so we said, you know, about the inverses of all them. Now the inverse of when we did the inverse of x, that gave us e to the power x. So the inverse of e to the power x equals ln x. So that x is equal to that x, and we can do it the other way around as well, because normally what we've been doing is getting from this point to this point. Now what we're going to do is going to get from this point to that point. So what we said was the inverse of this x, the inverse of whatever e to the power x, if e to the power x equals, gets us the value of x. Now this is the other way round. So we've already got the value of x. We want to know what that equals. So basically this 3.5 is equal to e to the power x. So that power x is 3.5. Hopefully that's explained it to you. And then that gets us this value here, whatever e to the power of 3.5 equals, which is that x, even though weirdly they seem the same. So if we do e to the power of 3.5 on your calculator, that should get you around about 33.115. Now the great thing about exponentials is you can always check you're right. So if we did the inverse, or the ln, of that 33.11, which copied in the answer, we get exactly 3.5, which is what we were told, what we worked out. So that's perfectly acceptable way of doing it. We've just got to know the inverses and what they're about. So I'll just go over that again in case you didn't get that. What we had was 1 plus 2 times ln to the power x equals 7. We cancel that down to get ln x equals to 3.5, and then we knew that that ln of that x in the brackets of ln is what e to the power x equals, hence 3.5 must be the power of x in e to the power of x. So that x in ln of x must be equal to e to the power of 3.5, and it is, and you can double check that by doing it the other way. That's a bit of a long-winded explanation. I'll just step back. Hopefully them arrows have sort of helped you understand it a bit better than I've done, that are over there. That's what I think anyway. So that x there, e to the power x, is equal to that ln of x, but that that ln of x is what that equals, that x. So e to the power x equals that, yeah? So we've got that. However, to find that, all we do is e to the power x to find that. But if we wanted to find e to the power x here, what we do is whatever that equals, so let's call that n, we do ln of n. And then that would get us x, which is that there. So hopefully that's explained it to you a little bit. Has it? Oh, it hasn't zoomed out. So hopefully, okay, so that e to the power x there, we're going to call that equal to n, and that is that number there, and then that x there is equal to that. And basically, this equation here, where we had it as that e to the in ln x equals 7 over 2, that was that equation there. So you can see that n is equal to e to the power x here. That is that n, but what that's equal to, so that's 7 over 2, is x, which is there. So basically all we did was put that, which is that, on there to get n. So hopefully that has explained it. I think that's probably one of the most trickiest one of them, but I'm just going to do another one now before we get kicked off. So that was the answer to 3.5. To 5A even in the book. Now this other one, that was struggling with me, and I didn't quite explain this. This question is going to help me with something I didn't explain in the tutorial very well. So this, just write the question out. Now you're probably thinking, looking at that, going, oh my god, how many e to the power x's and backwards, forwards, left and right, what are we going to have to do? Well, something I didn't tell you. The inverse of e to the power x is also equal. So e to the power x is also equal to log e to the power x. That's a natural log of x. That's what that is. So basically we'll replace all these with this. Get it? So what we do, this is essentially x, okay? That's x, that's x. So all these have a base of the natural log. So what we do with this is log e, and we put the x value, x plus 3, and this is where your C2 logarithms comes in. Take log e to the power x. Now you don't need to worry about these bases because e is a number, equals log e to the power 5. Now you should know when you take away logs you divide oh my god, the x's, I should know what they're called. So log e x plus 3 over x equals, and then we need to do log 5 in base e. So give me a minute to do that, because that's what that equals there. So log e, and then when you put e in there in your calculator, it comes up with the power and you just put 1. My calculator's gone a bit funny. And 5, so, and it gets you that answer. That 1.6, it's going to be equal to that. And now you should know, this is standard. That is equal to log a n equals x, and because a to the power x equals n, e to the power 1.609 is equal to x plus 3 over x. So if we take this back across here, we do e to the power of that. That gets us 5. So 5 equals x plus 3 over x. And we times both sides by x, so 5x equals x plus 3. So 4x equals 3. Therefore x equals 3 over 4. So that might have gone through it a little bit quick there, but basically we turned all them into logarithms because they're the exponential of it. It's the same thing. They're both the inverse of x. They're e to the power x, and that's the same thing. So basically we just replaced them, substituted it down, did our standard logarithm explanation, so that e there to the power of that equals whatever that is, as that rule states there. It's one of the basic rules of logs you learn in C2. And then we times both sides by x, and we got rid of the x at 5x equals x, take 3, removed an x from both sides, 4x equals 3, and then substitute it down, so x equals 0.75 or 3/4. Now you can check that. So if we assume I was right with the x was equal to 3/4, so what we do is we substitute x equals 3/4 into this equation. So ln of, so if we do ln of 0.75 plus 3, so if we do ln of 0.75 plus 3, that's 1.32. Take ln of 0.75, because we're just substituting x into the equation here. That's take away minus 0.28 should equal the ln of 5, which is 1.6909, and it does. So that is the same as that. Hence, we have proved x is the correct answer. So hopefully you've got that. How we did that, you can do that. So it's minus minus, so it's a positive. So 1.32 plus 0.28 is that 1.06 when you faff around with all the number stuff. So hopefully that's explained it to you. It's pretty simple stuff there, especially the C2 stuff. That's pretty straightforward. But hopefully it's been of some kind of help to you. And we'll see you in the next video, which should be... double check what it is. Which is which is differentiation.